Hi, my name is David Schultz. Welcome back to Our Earth, Its Climate, History, and Processes. Today, what we're going to learn is about the Earth's climate system. And the first thing that I want to talk about are the 5 components of the climate system: the biosphere, the atmosphere, the lithosphere, the cryosphere, and the hydrosphere. So let's go through each one of these individually, shall we? The biosphere. This includes all life, plants, animals, single-celled organisms on the Earth, in the water, on the Earth's surface, and in the air. There is the atmosphere. This is the gaseous envelope that surrounds the Earth. This includes not only the gases themselves and their chemical composition, but other substances that are suspended in the atmosphere, the liquid water droplets, the ice particles that comprise clouds and precipitation, as well as dust particles and other aerosol particles that are suspended in the air. There is the lithosphere. This comprises the upper part of the Earth's surface, maybe down to a few tens of kilometers deep from the Earth's surface. It doesn't include the deepest parts of the Earth's mantle, but that's for a different topic. We have the cryosphere. This includes everything that's frozen on the Earth's surface. We have the polar caps. We have glaciers in the mountains. We have sea ice and the permafrost, the frozen soils in the Arctic region. And we have the hydrosphere. This includes all the water substance on the Earth in its liquid form. So primarily the oceans and any fresh water in lakes, rivers, and groundwater. The next thing we need to talk about is how these different spheres interact. And for that, I want to introduce the concept of forcing and response. So when we talk about climate forcings and climate responses, you'll know what I mean. You can kind of think of this as cause and effect, with the forcings being the causes of something and the effect being the change that results in the Earth's climate system. So here, let me give you some examples that may help explain that. When we look at causes, these are, as I mentioned, external forcings to the Earth's climate system. These are plate tectonics, motions of the continents on the surface of the Earth being driven by processes deep within the Earth. We have orbital changes, changes to the orbit of the Earth around the Sun. We have changes in solar input. As the Sun goes through its evolution, it will change how much solar energy we receive on the planet. And I've also included anthropogenic or man-made external forcings on the climate. In this case, I've excluded man from the biosphere to emphasize the changes that we have made to the climate and how that might lead to some type of response. So these changes, these external forcings, then go through the Earth's climate system to produce changes in vegetation or the distribution of life on the planet, lead to changes in the chemical composition or the dynamics, the motion of the atmosphere, changes in the land surface as mountains rise up, as surfaces weather away, changes in the ice coverage and depth and volume of ice that we have on the planet, as well as changes to the ocean, not only the chemical composition of the ocean, but also changes in the circulation. So it's useful to think of external forcing and internal responses when we talk about climate system. This leads to another concept when we talk about forcing and response, and that is the idea of a feedback. And we're going to talk about 2 different types of feedback. The first one being positive feedback. This is a process internal to the Earth's climate that acts to enhance the original action. So in other words, if I make a change then this change will be amplified as the climate responds. Here's an example. We call it the water vapor feedback. The idea here is that if the Earth's air temperature increases, then the atmosphere has a greater capacity to incorporate water vapor into it. This will lead to an increase in evaporation, putting more water vapor in the air. And as we'll see, water vapor is a greenhouse gas. This will lead to an increase in the air temperature. So the idea here is that the positive feedback, that through the positive feedback, the initial increase in air temperature will put more water vapor in the air, which will lead to a further increase in water vapor, increase in the air temperature. And this is the positive feedback. An initial increase leads to a further increase. Compare that to a negative feedback. This is a process that counteracts the original action. So here we have the example of a cloud feedback, where if we increase the air temperature of the atmosphere, that again will lead to an increase in evaporation, which will put more water vapor in the air. More water vapor in the air means that it's more likely that clouds will be formed. This increase in the clouds may lead to more reflection of incoming solar radiation, and with less solar radiation reaching the surface of the Earth, then we will lead to a decrease in the atmospheric air temperature near the surface. So in this case, the negative cloud feedback of an initial increase in temperature leading to a decrease in temperature offsetting that. So through these different feedbacks, we see that the climate system can evolve in certain ways. As illustrated by these two specific examples, an increase in air temperature leading to more evaporation and more water vapor in the air, we don't necessarily know which is going to win out. And it may be that the positive feedback wins out in certain areas of the globe or in certain conditions, and the negative feedback wins out in other situations. So these feedbacks can be pretty complex. They may be interacting and they may be offsetting each other. So, but I want to introduce these terms because we're going to use them as we go through the course. So to summarize this lecture, we have the 5 components of the Earth system: the biosphere, atmosphere, lithosphere, cryosphere, and hydrosphere. We've introduced the concept of climate forcing and responses, the cause and effect of how climate can change over time. And then we introduced the concept of positive and negative climate feedbacks, and specifically gave you some examples of how this works, and told you that, sometimes they may offset each other and it may not be clear which climate processes dominate in any given situation. So thanks for listening, and I'll see you in the next video.